Welcome to the video lecture on the course Op-amp and linear integrated circuit. In this session, we will be seeing the topic of signal generators, and especially we will be seeing the derivation part or finding the expressions for frequency and amplitude of triangular or rectangular wave generated. We have seen the operation of triangular or rectangular wave generator using a Schmitt trigger and an integrated circuit in the previous session. In this session, we will be mainly concentrating how we can obtain the amplitude, that is the output voltage V naught, amplitude of output voltage V naught, and the frequency of the circuit for this particular type of circuit. So seeing the circuit diagram here, in this case, as we know, there are two parts. One is the Schmitt trigger, another one is the integrator in this case, and these are the waveforms what we had obtained in the previous case. In this case, now instead of taking it as UTP and LTP, we will name the amplitude as plus V ramp and minus V ramp. That is, the positive peak of the integrated output is taken as plus V ramp, and the negative part is taken as minus V ramp. Now initially, when the output of the Schmitt trigger, that is op-amp A, is plus Vsat, the output of B, that is op-amp B, steadily decreases till it reaches minus V ramp. When the output reaches minus V ramp, the output of A immediately shifts from plus Vsat to minus Vsat. Just before the switching occurs at a point P, a voltage at a point P is 0, which is nothing but mainly we are going to find the potential at the point P of this circuit, which is nothing but it is the input at the Schmitt trigger, input voltage at the Schmitt trigger, or voltage across the resistance R2. This means that minus V ramp must be developed across the resistance R2 and plus Vsat must be developed across the resistance R3. Seeing this particular case now in the circuit, so initially we have considered V naught dash. V naught dash is a positive value, which is nothing but at one end of the resistance R3, the voltage is at plus Vsat, and the other end V naught, which is connected to the resistance R2, voltage across the resistance is minus V ramp, that is the negative voltage. Therefore, the effective voltage at the point P is given as minus V ramp plus, that is across the, we are finding the potential across the resistance R2, which is using by the voltage divider rule, the R2 into plus Vsat, which is the voltage at the one end of the resistance R3, minus of minus Vram, that is the voltage at the other end of resistance R2, divided by R2 plus R3. So now in between the point as the integrator output voltage starts decreasing as a negative growing ramp, at particular point at a particular point the voltage becomes 0. So we will consider this particular part and find the expressions. When the effective voltage at point P is equal to 0 or 0 volt, so equating it equal to 0, we get minus V ramp is equal to minus R2 divided by R3 times plus Vsat. So we have got the negative voltage, or we can say this is the nothing but LTP value of a Schmitt trigger circuit. Minus V ramp is nothing but the lower trigger point of the Schmitt trigger circuit. Now to find on the other end plus V ramp, using the same concept. Similarly, when Schmitt trigger is at minus Vsat or a negative saturation value, now V ramp plus V ramp will be equal to minus R2 divided by R3 times of minus Vsat, and this plus V ramp is nothing but the upper threshold point of the Schmitt trigger. So we are getting the lower threshold point and the upper threshold point of the Schmitt trigger circuit. Now what will be the output voltage? Peak to peak amplitude of triangular wave is nothing but it is given by the expression V naught P to P will be equal to V ramp minus of minus V ramp, that is the positive ramp minus of minus, so it will be equal to substituting the values of minus V ramp and plus V ramp in V0 P to P expression, we get a peak to peak value of output voltage. And simplifying this, Suppose if we consider plus magnitude of plus Vsat, which is equal to magnitude of minus Vsat. Normally it will be nothing but VCC itself, plus 12 volt minus 12 volt. So amplitudes will be the same, and if we substitute this particular value, we get the expression for V naught peak to peak as 2 times R2 divided by R3 times of Vsat. So this is one part where we obtain the amplitude of the triangular wave, amplitude of the triangular wave, or we can say amplitude of the integrator output of a triangular wave generator. So V naught peak to peak will be equal to 2 times R2 divided by R3 times of Vsat, and the condition here is Vsat magnitudes are same. Now to obtain the frequency part, the time taken by the output to swing from peak to peak is equal to half the time period, so T by 2 what we consider. So in this case, this time can be calculated from the integrator output expression. So as we have seen in our integrator circuit session, V naught peak to peak will be equal to minus 1 over R1 C1 integral 0 to T by 2 for half time period minus V sat into dt. That is nothing but this is the input. We are considering the input as minus V sat for one of the half time period. So substituting this and integrating this expression, we get V naught peak to peak will be equal to V sat divided by R1 C1 into T divided by 2. We get a positive slope. We get a positive slope for the output voltage. So from that particular expression, we are finding the expression for time period. So T will be equal to 2 R1 C1 V naught peak to peak divided by V sat. Further substituting the expression for V naught peak to peak, we get the time period in terms of the saturation values. So both the saturation values gets cancelled. So we get T is equal to 4 R1 R2 C1 divided by. Now to find the frequency of oscillation f is nothing but f naught is equal to 1 by t. Substituting for 1 by t, we get f naught is equal to 1 by t, which is equal to R3 divided by 4 R1 R2 C1. And this is the frequency of oscillation. This is how we can obtain the amplitude of the output voltage as well as frequency of the circuit for a triangular or rectangular wave, where V naught peak to peak is equal to 2 times R2 by R3 times Vsat, and frequency f naught is R3 divided by 4 R1 R2 C1. Thank you for watching this particular video session.